How do you make soaps? In this video, I'm going to share with you the structure of soaps. So soaps are actually from the fats. The chemical name is triglycerides, and you can see that this is a long chain with an ester there. Under a very strong sodium hydroxide, this fat can be hydrolyzed to glycerol and also the sodium fats of fatty acids. So if you remember in my earlier videos in the ester, this is an ester and this is actually made from a carboxylic acid and alcohol in the first video, right? So making soap is actually the reverse reaction of the carboxylic acid with alcohol and form an ester. So soaps, making soap using a strong base, and most of the time they would actually use sodium hydroxide, will actually convert an ester. In this case, the ester is this fat. This is the ester structure, all right, and into two carboxylic acid and alcohol. All right. So this is the first reaction that we cover in the first video, how to make an ester. So with a strong base, sodium hydroxide, is called saponification. Saponification is the reverse of the esterification. Why I need you to know this is because they are related. Once you actually have carboxylic acid with an alcohol and a bit of acid as a catalyst, and you form an ester, of course you want to know the opposite reaction, that is saponification. Yeah? And saponification is being used industrially as well, because when you have fat, for example, coconut oil, you have perhaps avocado oil. You want to make soaps from coconut oil. You want to make soaps from avocado oil, the fat. Yeah, you can then convert the fat, that is the triglycerides, into glycerol and the sodium salts or fatty acid, and this will form the structure of a soap. Yeah, and if you look at the structure of a soap, as I mentioned earlier, it has a long chain. This is CH214. There are 14 of CH2. It's a very long chain. And what happens usually when we mix this with water, if you have water, you say this in a glass, right? This is water. But what happens is that the long chain will be usually, and say you have the sediment. This is the sediment, whatnot. Yeah. What happens is that the long chain will stay in the hydrophobic. This is hydrophobic. Hydrophobic sediment, and this is water, hydrophilic. Yeah. Hydrophilic. I hope you can see that. So now what will happen is that long chain will be on top here in the sediment, and you have the OH group, the O minus and AA plus in here. All right. So this is how, in a sense, soap works, in a sense, yeah. Or this is, you can also see it as a surfactant. Whatever the long chain is will remain in the hydrophobic section, and the short chain here, which is the more hydrophilic, will remain on the hydrophilic section, in the water section. Okay, so how do we do this in a sense? So it's a reverse reaction. So now if you have an ester, let me just draw this, the reaction. If you have an ester, so you have, say, an ester from the earlier ones. This is the ester. We're going to take that one, say R2. Then you have the carbonyl and you have R1. And the next thing is a simple general reaction. You have sodium hydroxide, strong one. Yeah. And what would happen is that you'd have R1 and then O. And the first thing that would usually happen is negative. That is, it actually formed a carboxylate ion. Okay, and then usually when you add acid in the workup, this is reaction. Usually, then when you would do the workup, yeah, you add a bit of acid. Only then it will transform into a carboxylic acid. Okay. So this is, let me just make it complete. Alright, so it's actually carboxylate ion, sodium carboxylate. Yeah. So how does it work? It's quite similar to, if we look at this, it's quite similar to this reaction where you swap the ester group R2 to R3, the transesterification, but now we have instead of alkoxide, we have the OH group, yeah, the hydroxide group. So we have there. Okay, now I'm not going to do any more colors. I think, and you are very familiar with the concept now. So I'm going to just put R1. Here is the ester. Okay, CH3. So we have here the OH. Alright, the hydroxide, and we also have, for example, Na plus. Right, so what happens, as you know it right now, like the alkoxide, that will attack the carbon in the carbonyl, that will go this way, and then this usually will be actually leaning to the right hand side. And then what will happen, let's just keep it as R1. Here I'm going to put is OH. Here is the O, CH3, and here is the O minus. Alright, and that's, it can be, you have sodium hydroxide, sodium. Okay, right. Now, since this group looks like, if you see like this, it looks like methanol. Yeah, CH3OH. Okay, so what happens is that now this can go back to here. You can then leave. This is a good leaving group. And what would happen is that, alright, so again the R1, then this goes back to carbonyl, that leaves off. This will form the carboxylic acid. Okay, but we have this methoxide ion. This methoxide, MEO minus, will then pick up this proton, and this will collapse, and it will form actually the carboxylate ion. Alright, so here O minus, which is very important, then the R1, Okay, and then you also have the accompanying positively charged sodium, and then you have the stable leaving group, methanol. All right. Okay, so this is the first. This is already the this is the saponification reaction. That is to make soap. Yeah. Then what happens next in the second part would be, because this is already an ion, this is already a salt. Yeah, this is already a salt. It's quite stable. All right. But what happens is that if you want this carboxylate salt, the sodium carboxylate, to form a carboxylic acid, you have to add the hydrogen during the workup. Workup is in the lab. Usually you will form the salt and it can crystallize out. And if you add an acid to it, and this will form the carboxylic acid. Okay. So that's all for saponification, is the hydrolysis of an ester, right, to form the carboxylic acid again. Now, let me then perhaps discuss one more reaction. If you have, for example, I love this lactone ring. I think lactone is a good example again. So if you have this ring, earlier we use a 500 ring, here we use a 600 ring, and this lactone. All right, and again, simple, very simple reagent. First, we're gonna actually keep it at the sodium hydroxide. You can probably guess now the product. So that will be carboxylate. Yeah, it'll be an ion. An ion. Yeah. So here we have. Let me just do this one first. If you only do one, the first one. All right. So that's the carbonyl, and then now it opens up. It will open up to form the alcohol at the end. So and this can be, if you want it to make a carboxylic acid, you have to add the acid at the end in the workup. So only then it will become carboxylic acid. That's the end of this video. If you have any comments or questions, please leave them in the discussion section. So I hope you see the similarities between the three reactions here. So first is how to make an ester. Second is how to swap an ester group, and third is, if you already have an ester group, how do you hydrolyze it? How do you return the ester from ester to form back the carboxylic acid and alcohol? So with that, I really hope that you learn something from these three videos, and also with the examples, it will hopefully illustrate the point. Make sure you go through the general reaction like this, and also the mechanism. There are also, one more thing, you really have to see the similarities and differences between the three reactions here. So thank you so much for watching the video, and I hope to see you in the next video tutorial.